All right, so here we're doing garden fencing. So a homeowner is building a fence around a rectangular garden. Three sides of the fence will be constructed with wire. The fourth is to be constructed with a wooden privacy fencing. The wire costs $2 per linear foot. The privacy fencing costs $6 per linear foot. And the homeowner has to stay within a budget of $320. So we're supposed to write a model for the garden, calculate the dimensions of the garden that will result in the maximum area. So this maximum area, that's going to be our part one. We need to go ahead and write that down. Part one is optimization. So for the output, we want to maximize area. Okay. And for input, uh, we need to calculate the dimensions of the garden. So dimensions of garden. Now that's probably going to be maybe an X and a Y, and I don't know. That's doesn't matter which one it is, but we do need to figure out which way we're going to do this. So if we say, because one of these is going to have a wood fence, and so let's call the wood fence X, and so this will be wood fence is going to be one side, and Y, that's going to be the wire fence. And this is $6 per foot, and this is $2 per foot. So that kind of, that we know what we need there. All right, so that's our optimization. Now what we need to do is kind of draw the picture. Okay, well, we know we're going to have something like this. Now, do we know which side is longer, which side is shorter? Not really. So if I put this as X and I put that as Y, then I know that let's call this one the wood fence. And then we'll say the wire is going to be those three. Okay, so those three are the wire fences. So this one and this one are Y. Now this wire is going to be X. It's going to be different than this one. So we kind of have to realize that that's going to be a case where we have a different side price than that side price. Okay. So now let's see here. So we have that drawn. We have all this labeled as far as prices. And one last thing is we have a budget of $300, $320. Okay, so that's going to be a key. Okay. So now let's kind of multiply everything out and start making up some equations based on our diagram here and prices and our budget. Okay, so that's what part 3 is to do. So if we do the wood fence, well, the wood fence, that's going to be a distance of X. And so then the cost of the wood is going to be what? Well, it's 6 times however long that X is, so 6X. Okay, now what about the wire fence? Well, that's going to be 2y plus x. And the cost of this one of wire, well, that's going to be, well, we said it was $2, so 2 times 2y plus x, or we can say that's equal to 4y plus 2x, okay? Now what else do we know? We know the total is 320, so if we take this plus this, that has to equal the budget. So then we can say, well, 6x plus 4y plus 2x equals 320, okay? Well, now we have common factors here, so we can say 8x plus 4y equals 320. Now, again, usually we solve for the x because that's going to be one of the variables, and then we can plug it into the other one and solve for y. So let's go ahead and solve this for y. So 4y equals 320 minus 8x, divide by 4. And so y is equal to, 4 goes in there, that's going to be 80 minus 2x, okay? So that's how long y is going to be, basically based on the cost, okay? Now, what can we do now? Well, now we need to figure out the area. Okay, so now we're out of room here. So now we have, what is the area here? Well, it's just going to be x times y, because we want to, again, we want to maximize that area here. So area is equal to x times y. We just found y. We said that was 80 minus 2x. So a of x is equal to x times 80 minus 2x. Okay. Now we distribute there. A of x is equal to 80x minus 2x squared. Now what we need to do is simplify and set this equal to 0 after we take the derivative. So let's go ahead and take our derivative. And what is that? Well, that's going to be 80. That's going to be minus 4x. Now we need to set a prime of x equal to 0. So if we do that, 80 equals 4x. X is equal to 20. Okay. And so that is going to be the distance x is. And we said x is, we're looking at feet. So this is going to be 20 feet of wood fence. Now what was y? Well, y was 80 minus 2x. So y equals 80 minus 2 times 20. 2 times 20 is 40. 80 minus 40 is 40. So y is equal to 40 feet. Okay. So let's draw our picture again. And again, we'll just draw it how it is, even though it's probably not correct because we said x was 20 and these are longer and that says y was 40 and these are shorter. So, sometimes you draw your picture without knowing what is going to be the correct way. But we said x was equal to 20. And so this x is equal to 20. We said y was equal to 40, and that y was equal to 40. So we then have the number of wire feet is equal to, and we have the number of wood feet is equal to. A wire is 40 plus 20 is 60 plus 40 is 100 feet, and wood is just 20 feet. So that is the the lengths of the wires or fences to create the maximum area with that constraint of a budget of $320. Now again, if we would have actually put the X's for the shorter distance, that would have been better. But this is how we drew it, so we got to keep it up that way, and we just have to realize that it's not to scale. So that's the key. And so again, the top one was our wood, and our wire was the 3 on the bottom and the left and right. Okay. And so we've optimized the area, and now it says, what is the maximum area? Well, max area is equal to 20 times 40. So that's going to be 800 square feet. So that would be our max area. What else do they ask for? How much of each type of fencing? Well, we need to have the 100 and the 20. Okay. And so that would be exactly what we need there. All right, so that's, again, another one where we had a square, we had to draw around it and figure out what it was, use our knowledge of what the area of a square is, the perimeter of a square, or rectangle rather, and we can then find all the different values for the given parameters that they gave us. All right, so let's stop there and come back with another.